Okay, so good afternoon. I'm the captain from TYPT, and as for my name is Li Yongzhang, and as for my member, here is 罗大钊、王瑞成、郑地阳 and 陈柏宇.
Okay, next will be Onya.
Hello, we are stage 11 from Jinghan High School, and my name is Lopez, 陈雅萍、黄晓婷、陈凯君、黄瑞群.
And the next one will be residents.
We are team residents. My name is Chosen Wei. This is Xiang Zhenhao. This is Mo Xun. This is Li Kairen. Thank you.
Okay, we have 5 juries. My name is Yu Jingdong from Kaohsiung 大学 and Professor Fu Zuyi from 台师大 and Professor Yang Dahui from 长甲大学 and 吴彦斌教授 from 张师大 and Professor Li Jinglong from 中正大学. Okay, so we are moving to the first stage for the challenge for the problem. Okay, so will be the problem 6. Then you should write down the presenter and the opponent and the reviewer. Okay, so later we will move on to the preparation of the reporter for 5 minutes. Okay.
不能发言超过3次。你们那个的有问题。那不是你们。
我其中有说，没问题的。可是有是说不能上次。我记得上面只是写 report。
必须经工作人员去确认。
工作人员去确认，我印象好像4名字好像没有次数限制。
之前我们那个像那种细节，而且被
有改成
还有3分钟，还有2分钟。 是可以。
所以要
他点不进去。
主要太在头上那个地方，这是带定了，先指定是带定好，不然怎么办？
那没关系，就是不影响那个其他前面先开始时间。软体的问题。
计时器可以再往下点吗？不要点不下去哦。
什么东西？要先暂停吗？还是不用？
没有，不用暂停啊。
如果是这样子，计时器可以点吗？
可以点吗？
你说往后吗？
不是，你现在在定啊，
你怎么样？
没有，现在他没有，就是要开始，可以开始。
哎，就撞墙，然后对来闯祸。
先报告吧。
OK. We guys are the reporter take stage.
And hello everyone, I'm from Team Arizona, and I will report the problem 6, non-contact resistance. And there is a problem statement. The response of the LRC circuit driven by the AC source, and they can be changed when we insert the non-ferromagnetic or non-magnetic metal rod in the inductor coils. And how can we obtain the magnetic and electric properties of the rod? And there is our key questions. The first one is, how does the LRC circuit change by the inserted rod? And the second one is, how can we obtain the properties of the inserted rod? Okay, and there is observations. As this video says, like this video shows, when we insert the ferromagnetic rod, the amplitude of the voltage decreases, and the left-hand side figures is the data from the oscilloscope. Okay, first we introduce about the LRC circuit. And the first one is inductors. Inductor is a coil, and when the current through it by the ampere laws, the inductor inside will make the magnetic field. But the inductor is in the AC source, it will make it the current will change through time. So by the Faraday's laws, they have make the electron multiforce to against the magnetic field change. So we have this relationship like this. Okay, and the second is capacitors. And we can see the capacitor as the two parallel plates, and when the current through it, it will accumulate the charge, and the charge can cause the electric field, and by Gauss laws, we can get these relations. And Q is mean charge, and C is capacitance, is a constant, and V is a voltage between the two plates. Okay, so if we ignore the resistance, we can have these equations. And this equation, like the object and do the simple harmonic motions on the spring. And the L is like an object mass. And the Q is like a displacement. And so this part is, this is like accelerations. And 1/c is like a spring the elastic constant of the spring. So we can have these equations. It's like a sine or cosine functions, and the angular velocity there is equal to square 1 over inductance times capacitance. Okay, and there is our experiment setup and the method. And like this figures show, this is inductor and this capacitors, and there is resistance there, but not they're very clearly to see. And there's AC source and the oscilloscope to get the data, and there is our figure how do we did that. And there's oscilloscope, and we use W to collect data and analyze it. Okay, and this page is about the lab you show, and there is the oscilloscope data, and there they can and fast Fourier transfer. So there, this is about the Fourier transfer figures. And there, this page is about our AC source frequency put. And by there, it's not clearly to show, but there can know about the peak-to-peak voltage from the circuit. Okay, we measure our appliance on the LRC circuit. The first one is inductor, and its value is about 2.1 0.56 microhenries, and the capacitor is about 155 mil farad. And by the LC circuit, we can get its resonance frequencies is about 255. Okay, and the problem says we need to insert a rod, and there are 3 types of rod. The first non-magnetic metal rod is about the copper and the aluminum. The ferromagnetic rod is the iron. Okay, so first we want to discuss about the probabilities. It's a magnetic properties. And when we insert a rod, and the rod material is a ferromagnetic, its definition is about its probabilities more bigger than the vacuum probabilities. It will make the magnetic fields more bigger as make the flux density bigger. So like this, and the flux density become bigger, and the electromotive or magnetic electromotive will become bigger too. So the inducement will become bigger, like this. And about the paramagnetic, the paramagnetic definition is about its probability is just a little bit bigger than the vacuum probability, and it will affect the flux density bigger, but very little. So, but you will still make the inductance become bigger. And about diamagnetic definition is its probability is smaller than the vacuum probabilities, and it will make the flux density smaller, but it's not very difficult, not very decrease about that. So, but you will also make the inductance smaller. Okay, and we want to introduce about the conductivities, and because inductor in magnetic field or inductor will change through the time. So if we insert the conductive by the Faraday's laws, and if the flux density change and you want to against it, so you will induce the AD currents to against it. You will make the B against, and it makes the flux density smaller, so the inducement will be smaller. Okay, and in my assumptions is we insert a rod in the inductor, just change the inductor inductance. So we use a inductor and resistance circuit to show that, and by Kirchhoff law we can get these equations, and substitute voltage because we use the sine wave, the AC input sine wave, so we can get this form, and we can get the equations like this. So by this equation we know the peak-to-peak current and the maximum of the current, and we can know the inductance. Okay, so first we insert a aluminum rod, and aluminum is paramagnetic, but its current is more bigger than the we not insert a rod because the paramagnetic affect very little, so it's the eddy currents affect more than the probabilities. So it will make the inductance smaller, and the impedance of the inductor will become smaller too. Okay, and we insert a copper rod, and the copper rod is diamagnetic, and its current will become smaller, and inducement will become smaller too. Okay, about the ferromagnetic, and as this figure shows, and the irons will make the amplitude decrease significantly. So the inducement will become very bigger, and inducement will become bigger. But the ferromagnetic rod also have the AD currents, but the probability affect more. Okay, and we want to detailedly discuss about the ferromagnetic rod. And we know when we put the iron in the magnetic field H and take the iron will become a magnet, and the magnet has its own flux densities, but the flux density has the maximum, and the maximum calls the Russian flux densities. Okay, and we think it's the parameters, but we cannot to know how does it will become. So we use a Hall sensor to make sure about it was a constant. Okay, and because we inserted iron rod, but iron rod is not not the constant when the currents become bigger. So we use a Kirchhoff, and we use the LRC circuit which driven by the AC source. And when the current have maximum, so the maximum the driving force was equal to the resonance angular velocities, and so it's like this, and the C is a constant, and the inductor is 1, so we can find the inductance. Okay, and there as we insert more a 10 cm in the inductors, so you can see that the resonance frequency is about 180, and we can know the inductance. And we insert 20 cm, and we insert the 30 cm. And when we insert more, and the inductance become more, because about the flux densities in the iron will be more significantly because the length about the iron is more longer, and will make the flux density more bigger. Okay, and there's a conclusions. And when the irons will make the current smaller, and the inductance become bigger. And alumini, well, when insert alumini, will make the current bigger and inductance smaller. Because about is a conductive plate and induce AC current, and the copper like this. Okay? And when the insert length about the iron rod longer, and the inductance will become bigger. And thank you.
Okay, we'll move on to the next page for the question of the opponent.
Okay, so thanks for the report of presentation and so can you first return to the page of your problem statement?
Okay.
Since the problem statement has mentioned that you have to obtain the magnetic and electric properties, do you consider the properties are from the LIC circuit resonance or the rod, inserted rod?
Inserted rod.
Okay, understand. And the second question is, do you consider that the magnetic and electric properties in your experiments, you only consider is the magnetic permeability and conductivity?
Yes.
Okay. And the second question, okay, so can you turn to the page you have do the setup?
Setup?
Yes, setup.
Sorry. There.
Next page.
Okay.
So do you concern that the peak of the fast Fourier transform you concerned in your experiment result because it seems that there are several peaks.
Yes.
From your data analysis, which seems that it's only have a main peak, do you concern that the several peaks are normal in normal condition?
Yeah, it's normal.
Okay, understand. And for the third question, can you turn to the back? Yes.
There.
As for the capacitors, like which type of capacitor you concern? Is it the polarity capacitor or without the polarity?
Yes, without polarity, because without polarity can use the AC to produce.
Okay, I understand. So it's because to fit in an AC source condition.
Yes.
Okay. And next, can you turn to the page we have discussed about the different materials of rod?
Like that?
Yes.
Okay.
Do you consider the length or the cross area of the rod?
The length we can control, but the cross area we can.
Okay, time's up. Okay, we'll move on to the presentation of 可以开始。
Okay, so good afternoon, honorable judges and fellow listeners. I'm the opponent for this problem statement, non-contact resistance, and I'm from Team Relativity. And here's the problem statement. A response of an LRC circuit will driven by an AC source and can be changed by inserting either a non-magnetic rod or a ferromagnetic rod. And firstly, we'll discuss about the non-magnetic and ferromagnetic definition further. And secondly is that how can you obtain the magnetic and electric properties of insert rod from the circuit's responses? And firstly, we'll consider that the opponent has only two parameters, which is the conductivity and the permeability. So we concern there may be more parameters or to concern in discussion. And as for the summary of the report, the reporter has used different magnetic properties, like such as we just previously mentioned is the conductivity and permeability, and also the electric property, and also the inductor, such as the Ampere's law and Faraday's law, and as a capacitor, the Gauss law to explain the LC component theory, and also use the Fourier transform and Kirchhoff voltage law to describe for its absorption. And as for the experiment, he used different material of rods, such as the ferromagnetic, magnetic rod of iron, copper, and aluminum. And as for the setup, they have used the oscilloscope to understand the resonance of the inserted rod, and also used an LRC component and lab view to understand the fast Fourier transform, and also the Hall sensor. And as for the reporter, we concerned that he has a complete qualitative phenomenon explanation on how the LLC circuit has been worked and well derivation from the oscillating of LC circuit to LLC circuit, and if they add an AC source, what condition will happen. And also he has a clarification of what the problem statement has mentioned is about the inserted rod. It's the response of the LRC component, not the inserted rod. And also he has a good experiment setup and have a qualitative understanding. But as for the suggestion, we concerned that he has lacked quantitative comparison between the theory and the equipment, since there's no fitting theory line that compared to the experiment results. And also they could have done more experiments to consider more parameters, and also they hadn't seen their page number, and more is that for the conclusion, one part is only the part they discussed is the inserting length. They only considered about iron in this condition. But in their experiment setup, they has concerned to use the copper and aluminum. So we concerned and discussed why in the experiment they only concerned iron in the inserting length. And for the discussion, firstly, we have some simple physics explanation of their assumption that they previously have mentioned. They'll ignore the resistance from the assumption. And secondly, is the qualitative understanding about how they discuss about the cross area and rods, because that, as we in the short question, we didn't. The reporter has mentioned he didn't concern the cross area of the rod, which may change the magnetic flux. And thirdly is the conceptual clarification of the magnetic properties, and also from discuss about the several peaks of the fast Fourier transform. Yes, and here let's go to discussion. Okay, so first, can you just turn back to the page of the problem statement? Yes. Yes. So as we have concerned that we discussed the responses, it's the magnetic and electric properties.
Yes.
Is it inserted rod properties or the surface properties?
If we want to get the rod properties
From the surface responses?
from the responses.
So are there several responses that you're concerned? Can you tell me some responses that you found to understand the
Okay,
circuit
so
properties?
about the magnetic properties and electric properties we find. Okay, and so if we consider, we can know about the ferromagnetic is about it has a very big probabilities, so we can know the result from the inductor will inductance will increases very big. And about the electric properties, we can know the conductive. And so when the conductive is good, and so your either eddy current or magnet is more bigger, so the flux density will about the inductors will decrease. So if the conductive is better and the induced amount becomes smaller more.
Okay, understand. But so as you're concerned, you just mentioned it's only the conductivity and permeability.
Yes.
So do you concern other properties?
And the ferromagnetic parts, we have to, well, initially we want to concern about the Saracen flux densities and the correlative magnetic field. But initially we find a series about the ferromagnetic core inductors, but we find it's not to match about our problem statement. So we just give up and maybe do it in the future.
Okay, so I'm concerned there may be some adjustments
Yes.
for this.
It should be adjusted.
Okay, and for the next question, can you just tell me other properties that you may think that also will affect?
Properties?
Yeah, but although maybe you didn't do those properties, but maybe there will be some properties like hysteresis or
Hysteresis?
magnetic hysteresis.
And when we insert magnetic, because the inductor work is about the change of the current, right?
Yes.
But if we put the magnet there, the flux density is a constant, so it will not change through the times. So, but well, it can the magnet like oscillations by the magnetic field, so it may make a sound
Like a
or
resonant sound.
oscillations. It's just an oscillations.
Okay.
The magnetic wall oscillations.
Then, so define this oscillation. Do you think it's a damping oscillation?
No, it's just this oscillation is just about the materials like wave, like sound.
Yes.
It's just the air's oscillation. It's not like a damping oscillation.
Okay.
It's just like
So,
sound.
in this condition, we can insert at other part, as the inserted rod has put in the coil. They'll have like some oscillations that you insert from the
It's
LC.
just for the magnet. It's just for the magnet.
Okay, so
magnet
it's
rod.
another kind of oscillation. It's in different conditions.
Yes, and this oscillation is about the current oscillations, but we insert the magnet is like sound oscillation. It's just like a movement.
Oh, I understand.
Yeah.
And secondly, that you have mentioned is the current oscillation, right?
Yeah.
So do you think the LRC circuit is damp current oscillation, right?
It's damping
Damping,
oscillation.
yes, damping
And yeah, if we not ignore about the resistance,
Yes.
it's a damping oscillations.
Okay, understand. Then can you turn to the page that you have ignored the
Or ignore the
yes,
resistance.
ignore? Yeah, that
Okay.
you have assumed for resistance.
There.
No.
Ignore
The
the
page you have discussed about the Kirchhoff's law.
Where? There.
The Kirchhoff's law page.
About the inductor and where?
Just you have an assumption that
There are lots about the Kirchhoff law.
that. Yes, this page. So can you explain what's the definition of Kirchhoff's voltage law and
okay.
why you have concern to use
Okay.
it in this?
The Kirchhoff law is mean where there is a dot, right?
Yes.
And the current through it, and the dot net voltage is 0. And so when the current is like there, and about the Ohm's law, we can know there is decrease about the IR, right? And when the through it, and by the inductor formulas, we can get will decrease like there, and well through the AC source, and they will get the voltage from there. So assumption that there is 0.
Okay.
Inductor is 0.
So in this condition, aren't there any capacitor condition?
Oh, because in my opinions, I think when we insert a rod in the inductor, their inductance will become changed and the capacitance will not change because it's not inserted to the capacitors.
Okay. Then can you turn to the okay, so the next we'll discuss about the cross area.
Okay.
So firstly you have mentioned you didn't first I have to ask you, do you think the size of the rod will affect this phenomenon?
The size is about the cross area.
as we previously mentioned that you have mentioned you have to do an experiment which discussed about the immerse depth, right?
Yes.
So I considered that the length of the rod won't affect this phenomenon clearly
Yes.
because you have considered this already.
Yes, yes.
So the size I'm meaning at this part is actually the cross area.
Okay.
So
And
let's
so-
move to the platform.
Okay. And about the cross area,
There will be a equation.
I think not quality, just about the maybe you have an equation and try that. Okay, and about when the third rod like this, and the assumption is their cross area is A, and because about the flux densities definition is about the magnetic field and plus areas. So because of inductor magnetic field change is you can see is a constant. It's not a constant. Its value is a constant. So you are fixed, right? You are fixed.
Yes.
And so when the cross area is bigger, and you will make the flux density change more significantly. So when the cross area is bigger and its eddy current or more bigger, so the inductance will become more smaller about the cross area. So the cross area is bigger and the inductance will decrease more.
Okay. So another question I have to ask is that as you concerned in this experiment, as if the rod is inserted to the coil like this.
Yeah.
So do you concern the eddy current will happen here, right?
No, it's but the current is not whole resistance, but all have the magnetic field. So there have some eddy currents, but there is more bigger.
So do you have a thought that you have concern to understand the magnetic and electric properties from adding some like a resistance to some kind of machine to measure the resistance by connecting only the inserted.
I'm not concerned about that but I think the resistance of the rod is not affect about this phenomenon because the resistance is just like a conductive. So I think not.
Okay.
And the size can change so much.
Okay, so next can you turn to the page that the conclusion has discussed about the several peaks of the fast Fourier transform?
And the conclusion.
Yes.
Yeah.
At this part, you have mentioned there are several peaks, right?
Yes.
So why they will have several peaks is normal?
It's pretty like the sound, and we use only frequency sound, and it's like melody frequencies, and there are decreases, but it's a times a multiple, has a natural numbers, so like a sound. Can you?
So like it's like some concept about the
maybe
wave
it's
that
like out the constructed interference and make the wave amplitude or more bigger, and but there is a logic. So maybe it's it initially is not very big like that. Like almost maybe like there just theirs and there's like theirs.
Okay, so as firstly you have measured you have calculate the resonant frequency is about 200, right? Then in your experiment it seems that that's more than 200.
I know.
Is this also because of the interference?
No, it's because the LRC circuit oscillations amplitude is not can compare with the AC source put. So their frequency is the AC source put frequencies.
So it's like kind of like the resonant frequencies.
It's dominant frequencies to this whole system.
Okay, understood. Then okay, so
Okay, time's up.不能去 summarize.
okay. So as for the concluding remark, we has discussed about the definition of the electric and magnetic properties. And secondly, we have discussed about that due to the opponent has considered several parameters, we have understand how other properties that will affect to the response. And for the thirdly, we have discussed about why the reporter has ignored the resistance in the circuit. And fourthly is the definition of the Kirchhoff's law. And fifth is that what will the size of the rods affect the results, since that we have discussed the inverse length won't actually has already been discussed. So what we have truly discussed is about the cross area. And we have understand that if the cross area is bigger, they will have more more magnetic flux in the rod. And next will be the conclusion here.
And then the user export.
Okay, and pick that or this.
And if what quality if is related to
Yes, because we initially our AC source frequency is about 1,000, so it's big about the natural numbers times the thousands. So it's mentioned and the big is about the thousands.
and if you do more in this situation, and if you do more experiment in this situation,
Oh yes,
there will be more fit.
yeah. If the x-axis well more longer, and there have a more several peak about the thousands like there maybe a peak, but the peak will decreases like this, and because there is a log, so actually the single is exponentially decreases, not like this.
And do you think resistance should be considered in this experiment?
You mean which experience?
When
You mean the electric resistance?
I think the resistance is just to know how does it work, but if you put the just inductors, and the voltage will not change and the current maybe will change, but it's more good for use the inductor and resistance to know how does the current is more. For me it's more easily.
And since that from the discussion we will understand the resistance of the rod won't affect the phenomenon, so I consider it won't actually affect the responses.
And you mentioned about the diameters of the rod.
Yes.
And what do you say about?
I consider that from the discussion, I think it will affect the magnetic flux through the equation he provided. The reporter provided.
time's up.
Honorable jury and fellow participants, I am the reviewer from the team and today I'm going to review problem 6, non-contact resistance. And here is the summary of the reporter for experimental. They use the S-field AC source, LRC surface meters, thrust and pole sensor. And they discuss about magnetic properties. And the variable is the material and the length. And for the theoretical, they use the Faraday laws, the Kirchhoff's laws, and the magnetic properties and the electric property, and the fast field form. And for the reporter's performance, the strong point is they have a clear explanation, and the source theory model and of the clarity setup. And for the weak point, there are lack of science introduction, and lack of quantitative data, and lack of comparison between the theory and the experience, and loss of the parameter. And for the opponent performance, they have good confidence and mention about many important questions, and have a clear set and real-time management. And in the discussion class, the opponent asked the reporter if there is only a peak shows on the equipment, is not normal or not. And the reporter responded yes. And in our opinion, it shows that the peak is abnormal because there are several peaks in the experiment data. And for the second question, the opponent asked the reporter, do you think the oscillation is a kind of damping? And the reporter responded, it is a wave oscillation. And in our opinion, we think it's a kind of damping because it decreases time. And for the third question, the opponent asked the reviewer, do you think the LRC circle is kind of damping oscillation? And the reporter responded, yes, it's a damping oscillation. And we agree with the reporter. And the next question is, do you think the size of the block will influence the cross area? And the reporter response is, if the cross area is bigger, the induced will decrease more significantly. And in our opinion, it seems the cross-sectional area will affect the result because it seems the induction is related to the magnetic permeability, and the magnetic permeability has a lot different in the air. And for this question, where there has several peaks, and the reporter response is a type of wave constant, and we agree with the reporter. And for the reviewer's question, because where the peaks will be lost as the experiment goes more time, the reporter response is yes, but it will decrease. And we agree with the reporter. And the next question is, do you think where the resistance should be taken into consider? And the opponent response is it won't influence so much. Thanks for your listening.
Okay, this will be the conclusion remark.
Okay, first we about appliances, we use the AC capacitors, and it's normal to get the multiple peak in the Fourier transfer. It's like a sound, like a single tone sound, and the cross areas increases, the magnetic field flux density will increases, so make the induced flux density will increases, so make the inductance smaller. And the front of the ILC oscillations in the AC source is driven damping oscillations. And when we insert a rod, in my opinion, the capacitor will remain constant. And the intensity of the about the resonance frequencies, intensities, and this several peak is decreased exponentially. And that's all. That's all my remarks.
Any question from the juries?
I have a question for the reporter. In the end, we were talking about the conductance was the iron layer increase.
Yeah, iron.
Aluminum and copper decrease.
Yes.
Why decrease?
Because
Theoretically.
theoretical is about the eddy currents, and eddy currents make the flux density in the
Any comment on the point?
My concern is because of the this one is ferromagnetic, one is diamagnetic, and one is paramagnetic. So the magnetic properties will be different. And as they observe that the magnetic flux will be very small in the non-magnetic conditions that there's from the properties they have mentioned.
So what if it's ferromagnetic materials? Then the conductance would be increase or decrease was inserted this one into the
Increase.
conductor. Increase, right?
Yes.
But the result shows decrease, right? I mean, for the aluminum and copper.
I see.
Sure.
And I think about the aluminum is probability and divide the vacuum probability is very small, so it cannot affect a lot about the about the flux.
Can you turn to page 13?
Sorry.
You got a LR circuit,
13.
and my question to you is that what essentially you measure? Because on the right you have a current equation.
And it's actually we find the
You know, I'm talking about
current.
the left-hand side.
Left hand side there.
The channel one, what do you measure?
Oh.
The channel one.
The channel one we detect under inductor. There is a there.
So essentially what do you measure?
We turn to the channel to measure the current.
Current is what you measure?
Current, yes, we measure the current.
No, that's not.
So we measure the voltage in under inductor.
Okay, what? Well, then, if there's no question, I can ask more.
So A, other question B. President?
I would like to say what is the non-contact resistance?
And non-contact resistance is mean there may be that the like a inductor impedance or the resistance from the AC source in inductor may so impact the resistance like the current will become smaller. Like there's if the inductance becomes bigger and the whole the current will become smaller. It's like a resistance effect.
Did you make this one in your experiment? Yeah, this resistance.
Resistance will not measure the resistance when the rod, not measure the rod resistance.
I think it's the resistance of the inserted rod, I think, due to that different electric and magnetic properties.
So this resistance is not enough, so it will influence the concept. Resist the resistance is the non-contact resistance is not in the surface of that's the concept.
So I got one more question. Question for the opponent. At one point you brought up permeability of these materials, and you also mentioned the conductivity of the materials.
Yes.
What do you think, with what kind of response you're gonna work out this permeability and conductivity? How are you gonna measure or whatever you're gonna come up with information relating to these two parameters?
So I think as for the permeability, it just from the reporter's report,
Well, your own opinion.
in my own opinion. Okay, so I think that the permeability may be that as we inserted the rod into the, okay, so first from the permeability, if we insert the rod into the coil, I think it will have some hysteresis, maybe, to understand the
That's
flux.
not what I was asking. I was asking what kind of response gonna lead you to understand the permeability of the materials inserted. What kind of response?
Kind of response.
That's fine.
Okay. So, report to review this comment. 67546. And for the opponent, 67557. And for the reviewer, 65445. And we have